Hello everyone, so this is Maurizio, editor of Power Electronics News, and today we will talk about isolation technology for high voltage, and we will talk about this technology with Azhar Mohammed of Texas Instruments, TI. Hi Azhar, how are you?
Hello Maurizio, I'm doing great and really excited to be here and talk about TI's newest product family, the Opto-Emulators.
Yeah. Indeed. So you are the product line manager of isolation at TI. So you manage a team of engineers focused on advancing isolation technologies. So tell me more about your activities, but in particular, what's news from TI?
Absolutely, Maurizio. Yes, I'm the product line manager for the isolation business in TI, part of the interfaces business unit. I'm responsible for digital isolators and isolated interfaces. So very excited to be here and to talk about the launch of Opto-Emulators. These are a set of products that are pin-to-pin to optocouplers, but at the same time, they are more reliable, more robust, and have much better signal performance than the existing optocouplers. We have already released the ISOM8710 to the market, and we are sampling the ISOM8711 and the ISOM8110. The first two are digital output, and the third one, the 8110, is an analog output opto-emulator.
So in this field that you are mentioning, there are high voltage isolation. So there are several technical questions, open issues that should be addressed. So for sure, research, innovation, development are needed. So you are introducing TI new Opto-Emulator, new Opto-Emulator portfolio of signal isolation semiconductors, with the goal to be designed to improve signal integrity, consume less power, extend the lifetime, and so on. Let's start with the Opto-Emulator and versus traditional optocouplers. So what are the key differences between these advantages applications in general?
Yes, Maurizio. If you take a step back and look at optocouplers, I mean, these are ubiquitous products. They've been around for ages. You and I have probably either used them directly, or they've been part of a system or a board, or we face some kind of challenges with these parts. The way the optocouplers are constructed is essentially there's an LED which transmits light, and it's an optical means of communication. And there is an isolation barrier, which is typically just an air gap. And one of the challenges designers over the years have had with optocouplers is that the LEDs age with time. The performance basically degrades with time. And even the isolation barrier, be it the air gap or something else, that tends to degrade with use as well, especially under duress, under the presence of high voltage day in and day out. The opto-emulators, on the other hand, use silicon dioxide as the dielectric, and it has excellent insulation properties. So that's the first difference between the two. In terms of advantages, if you look at opto-emulators, we support a wide range of temperature from -40 up to 125 C. And the performance is stable across this entire temperature range. The power consumed is lesser, the data rate is better, and one key difference as it especially relates to high voltage systems is the fact that the CMTI, or the common mode transient immunity, is significantly better for opto-emulators compared to optocouplers. And this spec, or this parameter, is extremely important when it comes to switching noise and how immune is your isolator to that switching noise. And our CMTI is significantly better than the optocouplers.
Good. So Azhar, if you have some schematics to show for our users, so feel free to share. So
absolutely.
Opto-Emulators, so improve performance over lifetime of end products by using TI proprietary silicon dioxide based isolation technology. So in comparison with others, let's understand the main features of this one. How does it compare in terms of dielectric strength that you mentioned before and performance to other isolation methods? So TI, please correct me, TI isolation integrated circuits use both advanced capacitive isolation and proprietary integrated planar transformers. So which tell us more.
Absolutely, you're right, Maurizio. We tend to use both, and it depends on the situation. One or the other provides advantage. But going back to your very first question, like I mentioned before, silicon dioxide is an excellent dielectric. If you look at the dielectric strength, it's about 500 volts RMS per micrometer, which is one of the best when it comes to insulating materials that are used in semiconductors for isolation. I would say another key advantage is that silicon dioxide does not degrade in the presence of ambient moisture. And there are some other dielectrics that tend to degrade when in the presence of moisture for prolonged time. The other thing we do is we build a multi-layered silicon dioxide structure. And that reduces the reliance on any single layer for high voltage protection. I would say the final thing about silicon dioxide is that we manufacture this in a very controlled environment in the wafer fab itself, unlike some other isolators, which are assembled together in an assembly site, and it might not be as controlled, as a wafer fab. So that gives us significant advantages, over other types of insulating materials.
So talking about reliability, so at this point, reliability testing. So silicon dioxide based isolation in opto-emulators extends the lifetime, but what kind of reliability testing or data can you share to support this one? Many high voltage isolation applications, as you know, are exposed to difficult environmental conditions, harsh conditions, so such as extreme temperature, humidity, vibration. So how can we ensure isolation components maintain the performance, the best performance and reliability under these conditions?
Yes, Maurizio. I mean, if you take either these opto-emulators or every single isolation device that comes out of TI, we go through a very, very rigorous certification process. There are third-party agencies across the world that test our parts and certify our parts. To do that certification, and even prior to it, there is a ton of testing, characterization, and qualification that happens on our parts. And one of the tests that we run is called time-dependent dielectric breakdown, or TDDB, which measures the lifetime of this device. And per the certification agencies, we need to guarantee at least 30 years. But through our testing, and especially with the properties of silicon dioxide, we are comfortably able to pass over 40 years of lifetime. And there are several other high voltage tests that are also performed both before the release of the product and during production. We run these high voltage tests at much higher spec values than even what we show in the data sheet. The other thing is the product qualification itself. You asked about temperature, humidity, vibration, etc. Our product qualification itself has all kinds of stresses. It could be voltage stress, it could be temperature stress, it could be humidity, it could be vibrations. All that is part of our product qualification, and we make sure all the results are on TI.com. So for any product, you can actually go on TI.com and get our qualification results. And also, our certification results are basically also saved or stored, on TI.com.
So talking about cost, this famous item, so high voltage isolation components are often expensive, so which can be a barrier to their adoption. How can we reduce manufacturing cost, but meanwhile, while maintaining or improving maybe the performance and reliability, as you mentioned, cost?
Yeah, Mauricio, I mean, that's a very important and very, very relevant topic, right? I mean, high voltage is taking off big time. Economies of scale are going to take place over time, and the cost is going to come down. But if you look at TI.com itself, if you look at TI itself, and you look on TI.com at TI's ambitions, one of our key ambitions, and every engineer at TI knows this, is to make electronics affordable through semiconductors. And there's a lot of investment, there's a lot of R&D that goes in process development and package development and material development with an aim to bring the cost down. Also, TI has been investing significantly in 300 millimeter wafer expansion. We have factories today with a lot of capacity that can support 300, and we are building a lot more capacity to expand our 300 millimeters footprint. And over time, the cost is going to come down, with that expansion as well.
So, could you provide information about or specification for different packaging options that are available for this new solution? I mean, and any consideration for engineers, for designers when selecting the right packaging for a specific application, maybe?
Absolutely. Mauricio, for us, the key goal with Opto-Emulators essentially is to match the packaging or match the footprint that optocouplers have today. So that's our, I would say, priority number one. The new products, the ISOM8710 or the ISOM8711, they are available in 5 and 4-pin SOIC packages. The width is about 4.5 to 5 millimeters, and the height is about 3.5, 3.8 millimeters. So overall, the area is about 17.5 millimeter square. We are investing in even more wider bodied packages and smaller packages as well for this portfolio, and you should be hearing announcements from us soon. In terms of reducing package sizes, I mean, that's something TI has been investing in over the years. And for digital isolation as well, it's been a big priority for us. Actually, if you go on TI.com and you look at a brand new part that we have called ISO8510, that's available in a QFN or a DFN package, which is just 3 by 2 millimeter square. And this is the smallest package in TI that we have for isolation today, and it's a 2-channel isolator. And we are listening, to customers, to designers, to come up with smaller and smaller package solutions. But we just have to keep in mind that, isolation requires some amount of width or creepage, as we call it, to be resilient to high voltages and prevent arcing and other things that could happen.
Oh, good. So, talking about applications for this new solution. So in automotive, industrial applications, for sure, space constraints is important, can be significant. As it's important also to develop compact, efficient isolation solutions that meet high voltage requirements, minimizing the footprint. Talking about application, automotive. So for the automotive version, the Opto-Emulator products expected in 2024. So which specific technical requirements, certifications are you targeting to ensure to meet automotive industry standards?
First of all, we will go through all the isolation certifications and make sure, the isolation itself is certified by the 3 third-party agencies, be it VDE, be it UL, or others. So that's extremely important, and that is needed for any high voltage applications. From an automotive side, we we stick to the AEC Q100 automotive spec, and all products are qualified per the spec. And there are a number of stresses that we perform, and pre and post testing to these stresses, and we adhere to the specification and make sure our product is compliant. And we implement also testing in production, again, to ensure that automotive customers are getting a high quality product, which adheres, to the certifications and the qualification specifications.
So I can mention battery management systems, BMS, traction inverters, like two of the most critical EV subsystems, maybe. So please correct me, where the 800-volt domain needs to be isolated from the chassis. So challenges, which are the challenges for isolation devices? Also talking about the switching, if we can say switching, from IGBT to silicon carbide, how does isolation design impact EMI, EMC, electromagnetic interference, electromagnetic compatibility in these EV subsystems? What measures are taken to mitigate possible potential issues?
I would say the critical requirement for any isolation device is to provide a barrier that can protect your lower voltage components like microcontrollers, etc., from high voltage spikes and other noise, and ensure they don't break down, one, under high voltage conditions, and two, in environments where there are very rapid voltage swings, especially, let's say, due to the traction inverter driver stage. Opto-Emulators, obviously, we have reinforced isolation, and we ensure we can withstand up to 10 kV of surge voltage, as well as having high immunity to switching noise. I spoke about the CMTI earlier. The switching noise immunity is measured through this CMTI spec, and our Opto-Emulators products have a much higher number or tolerance to the switching noise, compared to other products out there. When it comes to EMI, the process of like galvanic isolation itself, with a sturdy barrier like silicon dioxide, prevents electrical noise and voltage swings from propagating, to the low side, and just reduces the risk of EMI overall. And EMI risks, also arise if there are potentials for, ground loops, which can form when the, different parts of the electrical system could be at different, ground potentials, and it could result in the formation of ground loops. And essentially, these isolators help break these ground loops, and also thus mitigate, EMI concerns in that way as well.
So I was thinking one thing about EV chargers, or specifically for EV chargers. So how is the insulating material integrity maintained in charging cables and connectors, which are usually, I guess, frequently connected and disconnected? Are there some considerations, or is just no worries?
Oh, no, absolutely. Isolation is a very, very big care about. Just as important as EVs, the charging systems is also an extremely important, care about. You have high voltage charging here. It can generate EMI. It can generate electrical noise. It's extremely important, for our isolators to provide or to protect components on the low voltage side from potentially damaging electrical voltage spikes or noise, generated by high voltage charging. It's also extremely important to keep the communication intact in the presence of these, disturbances. So, we ensure we have very robust communication under these conditions as well. And we go through different types of qualification testing as well, that simulates different type of power ups and power downs, temperature, different types of temperature cycles, and all that is taken into consideration during our product qualification as well, so that, we have a robust product that can be used in these environments.
So another application, grid infrastructure, that for sure talking about EV, electric vehicles, I mean, grid infrastructure is another one. So energy infrastructure projects can vary in size, complexity. How can isolation devices satisfy from small to big, large scale applications while maintaining performance, safety, also reliability, just back what you said before?
Yeah, I mean, very similar to that. Again, grid infrastructure is a very, wide field, from solar inverters to EV charging to storage systems. I mean, isolation is used everywhere, anytime there is high voltage that comes into consideration, isolation, galvanic isolation becomes an extremely important care about. And TI by itself, has a wide range of solutions, that can satisfy at least the needs of grid infrastructure, be it isolated amplifiers, be it isolated gate drivers, digital isolators, or opto-emulators in this case. We have products that support different protocols, it could be as simple as isolation of GPIO signals to isolation of SPI or isolation of LVDS or USB, so different care abouts are taken into consideration with different products. We spoke about packages earlier, and again, if you look at solar inverters, there's a requirement to have extremely wide body packages, in some cases as wide as 15 millimeters. So we are investing in different products that can satisfy the need of grid infrastructure. In this specific case, our goal is to develop opto-emulators, which are pin-to-pin to optocouplers, and they can provide more reliability, more robustness, and better signal performance, when you replace them with our opto-emulators.
So indeed, so when we are talking about energy infrastructure, reliability is important. We can, of course, talk about cybersecurity. So in today's interconnected energy systems is important. So how do isolation devices would address these concerns about cybersecurity? I mean, but also interoperability. Just when in energy infrastructure, so often it involves various components, vendors. So how do isolation devices ensure this interoperability, compatibility with the different equipment, solution, communication protocols?
Yeah, excellent question, Maurizio. Essentially, isolation of signals that interface with the grid is extremely important. We have to make sure that the communication is robust and stays intact. That communication cannot break down, and when it does, it could potentially lead to other issues, and it could be taken advantage of. So for us, ensuring that our products have robust isolation, that's extremely important, and the fact that we support different signal standards. Like I mentioned before, be it SPI, be it RS485, be it CAN interfaces, making sure that robust, communication happens, by ensuring that the isolation barrier takes care of all the noise, and the communication medium can proceed, without any interruption. If you look at opto-emulators in particular, we are ensuring that we can support every type of signal that typically, interfaces within the grid. We are making sure that the data rate, is appropriate. We are making sure power considerations, are taken into account. We're making sure, the leakage is kept, at a minimum, and, making sure interoperability, across different standards is also, taken into account. So, this is just the start of the investment area for us. You will see more products, that we release, that take into account more, wider applications.
So just my last one questions about future developments. So you are introducing new opto emulators new portfolio of isolation devices with regard to extend the lifetime of high voltage application with TI proprietary silicon dioxide based isolation technology. Any tools, any resources for engineers, and what additional technical advancements or innovation we can expect to see from TI in the next in the field of signal isolation and high voltage technology.
So, Maurizio, as with any new product at TI, we have evaluation modules available, or EVMs for each one of these products. They're available on ti.com. In addition, we have a number of other resources as well. We have white papers, we have application briefs that the customers can take advantage of. Obviously, we have samples that we can ship to any customers who want to evaluate these parts. Like I mentioned before, this is an exciting area for us. We will continue to invest in this area. You will see new product announcements from us, every now and then, hopefully, on a continuous basis. And we'll keep you up to date with these product releases as well. So there is a good amount of effort and R&D that is going into either this area or all the other isolation and high voltage areas in TI. And, these are exciting times, for us as engineers to be a part of.
Thank you, Azhar. Thank you.
Thank you. Thank you, Maurizio.